Today I just thought we'd talk a little bit about batteries and the batteries that don't charge up. For example, this Ryobi, I'm blinking here that I have a defective pack. And we look at this battery. Actually, I'm going to look at this one first. They both show defective when they're charging. But a lot of people on the internet, and a lot of people even talk about just putting voltage across a battery and boosting it up. For example, this battery here is showing 8 volts. It's really low. Now sometimes these batteries, lithium, show low. They have transistors that actually cut off the actual voltage going out to the battery. They're not being used. And some of your new ones have a little bar that when you hit the button, it'll actually bring that voltage up and check it. The little microprocessor will do that automatically. But the problem I have with people wanting to put voltage across these batteries is they have no idea what's going on internally with the battery. And I've been repairing and working on batteries for a long time, and hardly ever is that a long-term fix because something is going on internally. Very rarely has a pack just gone down below the threshold voltage and beyond what the charger will give it to get it to pulse back up. So sometimes if you put voltage across and you think, hey, I got it up enough with a battery charged up, and it may have, but if you'll notice, that battery usually don't last very long. And we'll talk further into it once we get into this pack. This is a Ryobi P107. This little Ryobi, the little thin pack, is actually probably 4 years old, 5 years old. And it does have the security bits. This one in the corner right here has always got a cover over it. It's nothing but a little plastic plug. And once we get into the plug, we can just pop it off. We'll make sure we don't pull the wires too much on that tip. So the first thing I usually do, if I take a battery out and look at it, and these thin packs, just the single cells in series, are easier to work on because they're not as deep and not as many tabs across the battery, so you can get to the batteries easier. We can check our little thermal NTC that's doing the battery temperature. It's usually always on the side, and if you don't see much corrosion or any major issues or nothing on the actual transistors like they're bad, I'll go through and do a voltage check across the cells, because it's fairly easy to do because they're just jumping, like starting from here, negative, positive to negative, to positive to negative, and it's just going across. And we can tell that the board is monitoring each actual cell individually also, which is one hint that sometimes what the charger's picking up is something going on with one cell. It can pick that up, and it knows it shouldn't be charging it. Let's get the meter over here where you can see it. 3.2, 2.7, 0.2 volts. That's not good. I can stay on that same tab and go to the next one. 0.2, and this one's also 0.2. So this one's actually an extreme case, or more than one cell has went low, and either the actual protection cap on the positive side of the battery, some of them have, can pop almost like a, you want to look at like a fuse. It can interrupt and let go and open up. So either that's happened, or the cell has actually went faulty internally and the resistance has changed and it actually has pulled down that far. Now what happens sometimes with a cell like that, if you keep it charged often enough, you won't see it go down so far that it won't recover. And sometimes you see people get lucky putting voltage across, but it's not always a good thing. For example, I have another one. I've already taken it apart, and it is the same. It's the same model, the P107. A little bit different version because the plastic's a different color, but the boards look identical. I can't see anything, even the switches on them, and the surface mount LEDs for the battery monitor all looks the same. But on this one, this is a more usual case where you take it out, because it was also giving me a fault and not charging. And when I hit the button, it kind of blinks like a full charge and quickly drops. So right off the bat, I thought I knew what was wrong with this one, the way that indicator was working. But you see here on the meter, it only shows like 3.2 volts. If I wake it up by hitting the meter, it jumps up and goes to 13 volts. So if I flip this one over so we can see it a little better, let's go through the batteries real quick. Wow, that's almost fully charged. 3.99, almost 9. Well, there's a problem. 0.2. Fully charged and fully charged. Now here's kind of what I want to talk about. So if you put 20 volts across this battery thinking I'll bump it up enough where the charger will start charging again, well, one of two things is going to happen. Either the circuitry internally pick up that voltage is wrong on the battery and it still won't charge, or some packs will still try to charge to 20 volts. And here's the no-no. This one's actually showing shorted, because if it wasn't shorted, I wouldn't be reading almost 16 volts. So I'm just down 4 volts. So this battery has done something that's not that unusual and is showing like a dead short. Well, it's probably in the K ohms, but it's still low. It should be a very high resistance, and it shouldn't actually deplete very much at all, just sitting there. But this one has went low ohms internally and went to 0 or to the low K ohms. And that could be a very bad condition trying to overcharge this battery. For instance, if we just look at some specs here. This is another cell out of a Ryobi battery that's good. This cell came out of a Ryobi battery that the pack had failed and had some bad cells, but this cell is good. So using this data and the actual data from the battery on this pack, on this 107 pack, we can just look at a few things here. And you never want to mismatch your capacity, obviously. So just comparing these two, they're not real far off, but we got a 1300 milliamp versus 1500. Our constant charge is 4.2 like our standard charge level. That's the same. 100 milliamps and 0.91 amps, really close on the standard charge, or this is fast charge. So the standard charge is showing 50 milliamps. So the Samsung cell is showing a little bit higher charge, a faster charge rate. Maximum charge 4 amps and 4000 milliamp, that's the same. If we look here though, we got a discharge or a cutoff voltage, and one battery says it don't want to go below 2 volts and one says 2.5. But either way, I usually go by 2.5, but some cells will let you go below 2 volts. But usually if a cell goes below 2 volts, the manufacturer won't try to charge it anymore, because something in that cell has went wrong for it to drop below that level, and it might not be safe to charge back again. Have I sometimes had luck doing it? Yes, sometimes you will. But in the case of this battery, I absolutely would not do anything but just replace that cell and that battery. So I have done some videos where I showed a cell being replaced, but I will do this one really quick. Usually I have luck separating it out, but being in the middle and that just didn't want to flex, I did have to cut on the other side right here just to give me a little bit more flex, and I can put hot glue or whatever back over this later after I test it. But you do have to get a little bit of flex here. The only other alternative, you can actually take them all off of one side and solder them back on. This is the route I chose to be easier on this one. But I do it on the negative side because you don't want to short out. Even though this cell is dead, it's just not a good habit of shorting around the positive to the negative. On this end is all negative, so if I pry, you'll see me prying on the negative side or working with the negative side, and that's the reason for that. So we got the one that's bad out. Just going to get the replacement cell. Since this is an older pack, I am going to put the little bit smaller milliamp rated battery in. It's also a Ryobi cell. Alright, back now. I just used a little bit of hot glue and I just filled in that spot to keep it secure. It's not like it's really going to go anywhere in the bottom of that battery housing, but that'll give it some extra protection and keep it secure. Very rigid. Now we're just going to secure these. You can either spot weld it, or I'm just going to solder it. I've had good luck soldering, just keeping a damp rag or cloth close by. We'll put a little bit of flux on there. It's got a good connection on that side. Put some RE flux on this negative side. Sorry, covering up the shot there a little bit. That's got a good connection on the negative side and the positive side. And we show our 19.6 volts. So that looks a lot better. I'm just going to put a top on here temporarily. Says we're charging so far. We'll let that sit there for just a minute. We'll come back. Back with a drill. Got a little 90-degree drill here. That's what I believe is the right way to repair a battery pack. Most battery packs are going to have issues with cells. Some may have issues with the BMS or the circuit board. 9 times out of 10 it's a cell, and this one is not as common where it's got 3 out of the 5 cells bad. But I say the batteries are 4 to 5 years old. I hadn't had a whole lot of issues with them, but this one I'll save the spare parts because I believe the board is okay. And I believe 2 out of the 5 cells may be okay to put in another pack to get another one by. But since there's 3 out of the 5 bad, the sale's about $5 a piece, just on average, somewhere in the neighborhood, or $4 to $6 a piece, depending on what the sales are. So sometimes I do, as I repair packs and repair things for other people. So I'll probably just keep that one for spare parts. On this one, this is actually a P103, so it's a little bit older style Ryobi, the compact model. It actually doesn't have the indicator like the big ones, or the new compact ones, of course. Tight. Snug right there. That is made quite a bit different. We can compare the two because I didn't put the other one back together. A lot easier to replace the cells on this one without the cage. They just relied on I actually like the older style better in that regard. Just get right to checking our batteries. Can't see that in in the shot there. Got 4.1, 4.1, 4.1, 4.1, and 4.1. Boy, those cells are all jammed up. And there's our 20. From here to there. There's our 20 volts. So even though this is a lot older pack, it's actually in good condition. So there's just a look inside of an older pack. Still in really good condition with those same cells. Yep, same cells. So I hope you enjoyed the video today about the repair of the Ryobi P107 pack. There'll be more battery pack videos in the future. If you like the video, please share, like, and subscribe. Thanks for watching.